Very good evening to all. In today's class, we are going to start exercise 7.4. Here we are going to learn few special integral formulas. First, we start with 6 formulas and then we will see how to apply these formulas into the sums. So here are the formulas that we use in this exercise initially. And I have separated these formulas as type 1, type 2 and type 3. Type 1, type 2 and type 3. Type 1 are those formulas that comes from the antiderivative properties. So that means everything comes like that only, but this we already learned. Differentiation and we have extensively used this. So this is easier to remember. Integration of 1 by a square plus x square. Just revise what you've learned in inverse trig and as well as in differentiation of inverse trigonometric function. Differentiation of tan inverse x is 1 by 1 plus x square. So here integration of 1 by a square plus x square, wherein a can be 1 or any number, will be 1 by a into tan inverse of x by a plus c. Then their differentiation of sine inverse x used to be 1 by root over 1 minus x square. Here integration of 1 by root over a square minus x square is sine inverse of x by a plus c. A can be a 1 or any number. Alright. So the first two formulas are directly we can consider from the differentiation. Next one. Type 2, 1 by x square minus a square form and a square minus x square form. So if it's x square minus a square, it is 1 by 2a into log of x minus a by x plus a. If it's x minus a over here, it would be x minus a over here also. And if it's a square minus x square, it is x plus a or a plus x by a minus x. That's the only difference. Rather than memorizing it blindly, it is important to see the difference. Then it's easier to keep in mind. Type 3, root over square minus a square, 1 by root over x square minus a square, and 1 by root over x square plus a square. Here, if it's x square minus a square, it's log of 1 plus log of mod of x plus root over x square minus a square, because it's x square minus a square here. If it's x square plus a square, log mod x plus root over x square plus a square. So this way the 6 formulas we separate as 3 types. Now before we use these formulas into the sums, there are certain rules that we need to keep in mind. Rule 1. No coefficient for x square term. Make sure that before you apply this formula into the sum, there is no coefficient left in the question. If there is any coefficient, please try to remove that. Rule 2. The numerator must be 1. The numerator of the function must be 1. Only then you can apply this formula directly. Otherwise, you have to do some work. So keep in mind these 2 rules before we start this exercise. Question number 1. Integration of 3x square by x power 6 plus 1. Here rule 2 is not followed. The numerator is not 1. So I need to do some work in order to get rid of this 3x square. So now I'm going to write. So we write x power 6 as x cube with a whole square and then consider t as x square. When t is x square, dt by dx is 3x square. So dt by 3x square is dx. Get rid of this 3x square using this. So this will transform to dt by t square plus 1. Now this is in the form of 1 by x square plus a square, wherein x square is 1 square and t square is x square. Remember, x square is 1 square and t square is x square. Just apply the formula, put the value of x and a in their right places. You will get 1 by 1 equals 1 by 1 into tan inverse of t by 1 plus c. And later in the end, substitute the t that we assumed. So that's the answer for the first one. Tan inverse x cube plus c. Now the second one. 1 by root over 1 plus 4x square. Here rule 1 is followed because the numerator is 1. The denominator rule 2 is followed, rule 1 is not followed. So denominator contain x square and x square have a coefficient here. So I cannot use that formula straight away. So I have to do something to get rid of this 4. So we multiply and divide by 4 inside the root. Please keep in mind that we are multiplying and dividing inside the root like this. So the by 4 will get divided here. The into 4 will come out as 2. Then it will be root over 1 by 4 plus x square. 1 by 4 can be written as 1 by 2 the whole square. Now this is in the form of 1 by root over x square plus a square, which is this. Now in the place of a, we substitute half. In the place of x, we substitute x. So with this, we get this. Now, if you check your book back answer, that will be slightly different. The book back answer would have been this, and this is what we get. Now, for that, a little more simplification. Expand this. 1 by 2 the whole square is 1 by 4. 1 by 2 the whole square is 1 by 4. So you get mod x plus root over 1 by 4 plus x square. Half and log will stay there as it is. So half log, complete the LCM. So we get mod x plus 1 plus 4x square root by 2. Root of 4 is 2, so then 2 comes to this side. So half log mod 2x plus root over 1 plus 4x square by 2. This means log a by b. So that becomes log a minus log b. And then this is log a by log a by b. Log a by b is log a minus log b. So you get half log 2x plus root over 1 plus 4x square minus log 2. The half is common for both. So you take this half log 2 along with c and you consider that as a constant, and it is a constant. So half log 2x plus root over 1 plus 4x square plus c is the answer. C outside the bracket. Let's put a mark here. So that's the answer. So now the fourth question. Oh no, before that let me explain the third one to you. Third question is integration root over 2 minus x the whole square plus 1. The problem is instead of just an x square, we have an expression over there, which is also not allowed. So we take t as 2 minus x and then follow the substitution process. With that, the dx becomes minus dt. The minus comes out, so it's dt by root over 1 plus t square. Now it's in the formula, right, of 1 by root over x square plus a square, which is log of x plus root over x square plus a square. X is t here, so wherever x is, you substitute t, and later whatever you assumed as t, you substitute that also. Then since there is a minus out, it will come in the power, and since it's in the power, it is log 1 by 2x by root over 1 plus 2 minus x the whole square plus c. So this is question number 3. Now question number 4. Question number 4, 1 by root over 9 minus 25x square. Now here x square contains coefficient which is not allowed if I have to apply the formula. So inside the root, which means inside the root, I'm going to multiply and divide by 25. When I do so, the into 25 will come out of the root as 5. So it will be 1 by 5 into root over 9 by 25 minus x square, because it's 25x square by 25. This will become 1 by 5 integration of 1 by root over 3 by 5 the whole square minus x square. Now this is in the into dx. This is in the form of 1 by root over a square minus x square. Use that formula and get the answer. So here is the question number 6. Integrate x square by 1 minus x power 6. So what is the problem? The x square is the problematic term. I should be having 1 there only, then I can use the formula. So do something so that I can get rid of this x square. X bar 6 can be written as x cube the whole square. Now consider x cube as t. Follow the substitution process. You will end up by getting dx as dt by 3x square. So eventually the x square term will get cancelled. You will get 1 by 3 into integration of dt by 1 plus t square. Then apply the concerned formula. You will get the answer. Question number 7. Question number 7 is integration of x minus 1 by root over x square minus 1. So the problem is the entire numerator that we see here, x minus 1. Now what is the way to get rid of that? If it was x, I would have gone for substitution. But it is x minus 1 here. So I'm going to separate the term x by root over x square minus 1 minus 1 by root over x square minus 1. Like this. Now this one works with substitution. So if I take x square minus 1 as t, the x will get cancelled. But if you just take x square as t, then the x will get cancelled, but you get root over t minus 1, which will put you again in a stage where you have to use substitution once. So it is better you consider x square minus 1 as t instead of just x square, because anyway differentiation of 1 is going to be 0 only. So therefore I took t as x square minus 1. dt by dx is 2x. Substituting back into the question, I get half integration of dt by root t. Root t to integrate, you take it up, so root t to the power is minus half. Follow the integration process, you get this. Substitute t back. The next term which I haven't integrated is in the form of special integral, in the form of 1 by root over x square minus a square. So follow the formula and that's it. 8th question. Integration of x square by root over x bar 6 plus a bar 6. So the problem is the x square term. Somehow I have to get rid of this x square. I have no issues with this a bar 6. This will not hinder us from using the formula. This will not stop us from using the formula. So a bar 6 is fine. The problem is this x square term. So somewhere we need to find a way out to get rid of this x square. Then x bar 6 can be written as x cube with the whole square. As again, take x cube as t, differentiate it, express, follow substitution process, convert the question in terms of t. Then we write a bar 6 as a cube the whole square. A cube the whole square. Now it's in the form of 1 by root over x square plus a square, which is log mod of x plus root of x square plus a square plus c. Substitute t and x back into the question, t back into the question, we'll get the book answer. Now coming to question number 9. This is, when you look at the question, you know how to solve it. T, if you take t as tan x, dt will cancel the secant square x. So this will directly come to a form of dt by root over t square plus 2 square. Apply the concerned formula, you will get the answer for the 9th one also. So question number 10. 1 by root over x square plus 2x plus 2. Now here, in so far whatever we did, there was no x term in that. There was only an x square term. But now it is x term is there. So we need to complete the square and make this into a proper square. So using completing the square method for x square plus 2x plus 2. Now completing the square is a very old method, and I think consistently we are learning this from 10th standard. Now x square plus 2x plus 2, the rules to be followed. Rule number 1, do not have a coefficient for x square. Make sure that there is no coefficient for x square term. And if there is one, get rid of that by multiplying and dividing by that number. Say if I have a 5 here, then I'll multiply and divide by 5, so that I can get rid of that particular number. So that is rule number 1. Rule number 2, group the x square term and x terms. After you get rid of the x square term, x square coefficient, group x square term and x term. After grouping that, consider only the coefficient of x in the rough column. You can see me writing here. Consider only the coefficient of x, not x term. So here it is 2. Divide that by 2 always. This divided by 2 is not because this is 2. Generally, because of 2ab, we divided by 2. So whatever be the coefficient of x, always divide that by 2. We get 1 here. We might get different numbers in different cases. So once you find a number, insert that number after putting a square on top of it and in plus and minus form. So simply take the x coefficient, divide it by 2, always what number you get, put a square on top of it and insert it back into the question in plus and minus form. So I got plus 1 square and minus 1 square. So I added plus 1 square and minus 1 square. Now I'm going to rearrange this. So x square, 2x plus 1 square comes in a bracket. Plus 2 and minus 1 square is minus 1. This is a plus b the whole square expansion. So plus 1 the whole square plus 1 square. Now that means the question has come to a form of 1 by root over 1 by root over x plus 1 the whole square plus 1 square, which is x square plus a square form. Well, if you want, you can take t, but it's not going to make any big difference. So you can directly use the formula. Because when t is x plus 1, dt equals to dx. So even if you skip this step, it's fine. But if you have a doubt, better you follow all the steps. Question number 11. 1 by 9x square plus 6x plus 5. Here we have coefficient for x square, so I multiplied and divided by 9. Into 9 stays out, by 9 is dividing all the term. With this I am getting x square plus 2 by 3x plus 5 by 9. Then I said take the coefficient of x to the rough. So coefficient of x is 2 by 3. I took this to the rough column, divided by 2 always. So 2 by 3 by 2 is 1 by 3. And 1 by 3 square is plus or minus 1 by 3 the whole square. So I am inserting plus 1 by 3 square and minus 1 by 3 square plus 5 by 9 comes as it is. Now make sure that when you insert this plus and minus number, it is inside the bracket and 9 must be outside. Do not miss this 9, otherwise everything will go wrong. Now 9 into a square plus 2ab plus b square, which is a plus b the whole square. The remaining numbers are simplified and they come to this form. Insert this back into the question. We get 1 by 9 dx by x plus 1 by 3 the whole square plus 2 by 3. Now take t as x plus 1 by 3, apply the formula and get the answer. Question number 12. 1 by root over 7 minus 6x minus x square. Now here x square and x term is negative. So before you, there is no coefficient other than minus 1 here. But it's negative. So preferably take the minus out right in the beginning itself. So I took the minus out, so it's plus 6x and plus x square. Now I take the coefficient of x to the rough column. So it's 6. And I divide by 2, so I get 3. Whatever number I get, I'm going to add and subtract that number with the square form. So plus 3 square and minus 3 square. Then it's x square plus 6x plus 3 square makes a plus b the whole square form. And minus of minus 3 square is plus 9. 7 plus 9 is 16. So 16 minus x plus 3 the whole square. This comes to the form of 4 square minus x plus 3 the whole square. Insert this back into the question. You come to this form. Then use 1 by root over a square minus x square formula. So this is how we solve the 12th one. Now I completed till question number 12. The same pattern is followed till the 16th sum. For the 13th sum, multiply x minus 1 and x minus 2. You get a quadratic equation. Complete the square, then use the concerned formula. The 14th one, x square term is negative, so from this take minus out. Follow the process as we did in the 12th one. For the 15th one, just like 13th, multiply this term. Find the coefficient of x. divided by 2. Square the number, insert in plus and minus form. The only difference is here it's a variable, previously it was numbers. So you have to be a little careful while doing this. 16th one, when you see a sum, don't jump to do completing the square always. Sometimes substitution can be very easy or it will come handy. Like here, if you take 2x square plus x minus 3st, dt will cancel 4x plus 1. So this will directly become 1 by root t into dt. So no need of any formula. So with this, we complete the first set of questions following these patterns. Today, the remaining let's do it in the next video. Thank you.